Welcome back to the Mechanics of Solids lecture series. We're working on internal shear and moment functions in beams. In this video, we're going to conclude the example we were working on previously by drawing a shear force and bending moment diagram from the shear and moment functions that we evaluated previously. Notice that I've recorded the shear and moment functions for each region for reference, as well as extended the lines down for each region so that we can easily plot our shear force diagram and our bending moment diagram as shown. One more addition. In this case, since we are not working with symbolic functions but actually have numbers, it's important to note the units on our shear force diagram, which is going to be kips for shear force, and for bending moment diagram our units will be kip feet. Okay, let's start with region 1. In region 1, shear force is equal to 0, so we just draw that as a straight line across the axis, and the moment is equal to a constant, a negative 120. So I'm going to draw that as a negative and a straight line for a constant function. It's negative and the value is 120, which I can locate somewhere along the diagram. Now let's look at region 2. V of x equals negative 5 times x minus 8. Notice that when we evaluate that at x equals 8, it's still 0. If we evaluate this at x equals 14, we get negative 5 times 14 minus 8, or negative 5 times 6, which is negative 30. So I'll drop down and draw a straight line in between, since it's a linear function. It's negative with a value of 30 at the end. And now notice that my reaction is also equal to 30. And this is a good check, because it tells me my shear force diagram is going to jump up at the end by the amount of the reaction, and it should go back to 0 at the end. So that tells me that it looks good. Now my moment function in region 2 is negative 120 minus 5 halves x minus 8 squared. This is a quadratic function, so we're going to draw the diagram as being curved in that region. The value of the moment at point B, x equals 8, is just going to be negative 120. So there's no discontinuity in the moment from region 1 to region 2. The value of the moment at the end of the beam, m at x equals 14, would be equal to negative 120 minus 5 halves of 14 minus 8, or 6 squared. And notice this is very similar to the calculations when we were solving for the reaction, equal to negative 210. So this moment function is going to drop down to negative 210, and as I mentioned, we're going to draw it as a curve in between those two regions, a quadratic function. Also negative, make sure we note the value at the different locations, 210, and then because the reaction concentrated moment is equal to 210, then the diagram will jump back up to 0, which is a good check. And we'll talk more about these checks when we talk about graphical rules for plotting shear and bending moment diagrams.